Alright, this is a video assignment for chapter 12. The question asks, the equilibrium constant Kc for the reaction is red spheres plus blue spheres turning into the red and blue is 3. And so that's the first thing I wrote down, is Kc is equal to 3. Consider the volume to be 1. The volume, as far as I know, doesn't really matter as long as it's not changing. Does the situation depicted in the figure below correspond to the equilibrium? If not, in what direction will the reaction proceed in order to obtain equilibrium? So, I believe what this is asking is the ratios of the red and blue spheres to the red and blue combined spheres. Do the ratios correspond to the ratios at equilibrium? And the way I checked this, I counted up all of the red spheres and then all of the blue spheres, and I got 18 for the red, 24 for the blue. Then I also counted up the red and blue spheres, like when they're combined, and I got 10. And to figure out the equilibrium constant, all you have to do is take the concentrations of the product divided by the concentrations of the reactants. And so that's what I've done. And I got this number, 0.023. And so this is basically our, how do you say this? I'm just going to call it the constant. This is basically the constant for the ratio that it's giving us in the picture. And comparing that to our equilibrium constant, the constant we know it'll be at the equilibrium, it is much less. And so in order to reach equilibrium, you would have to make that constant bigger. And the only way you could do that, let's look at this equation. What can you do to make this number bigger, closer to 3 I mean? Increase the number of red and blue spheres together, because you'll have a bigger number in the numerator divided by the reactants, and that will hopefully get you to a higher equilibrium constant, or just constant, I guess. And that means it'll shift to the right, is what I'm saying. So more red and blue spheres would need to be created. But yeah, that's my answer.